Ladies, gentlemen, honorable assistants, Assalamu alaikum. I have the honor to present my study entitled Investigation of Facilities Tomo 40 as a green inhibitor on mild steel corrosion in acidic media. For this, I will start with an introduction, results and discussion, and finally a conclusion. Corrosion is an electrochemical process takes place between metallic materials and environment that causes degradation of metals, which results environment and process pollution, economic loss, and safety of process. Corrosion leads to serious problems such as changing physical appearance, mechanical properties, and resistance of materials. One of the most affected metals by corrosion is mild steel or its alloys, which are the most important and widely used metals in various industrial and engineering applications due to their low cost, high ductility, malleability, good mechanical resistance, and easy availability. Recently, corrosion protection studies have been focused on the use of non-toxic and effective inhibitors, which are mostly called as green corrosion inhibitors. Those inhibitors are generally obtained from natural products as extracts from the leaves, seeds, hardwood, bark, fruits, and medicinal plants. As it is summarized above, there were many extracts applied as corrosion inhibitors for protecting metals. Most of them are local. Therefore, enrichment of local and natural compounds for this aim is very beneficial for industry. Celtis turnipoti is a deciduous tree usually about 5 meters tall that grow in high temperature and tropical regions. The edible fruits of this tree are popular in many countries including Turkey, Ukraine, Croatia, Greece, Iraq, Iran and Azerbaijan. The fruiting buds of Turkish Oriental blackberry are popularly known as Gardahan or Doğu Jitlenberry by the local people in Turkey. The fruit of this plant has high nutritive properties. Its fruits and seed contain high levels of calories, phosphorus, vitamins, and other minerals. Also, it's very rich in protein and fat compared to other fruits. To our best knowledge, the extraction of Celtis turnipoti, which is commonly available in different countries, was studied as natural corrosion inhibitor for mild steel protection in 1 molar HCl. Various electrochemical microscopic techniques and contact angle measurements were used for this study. The potential dynamic polarization plots for mild steel in 1 molar HCl solution without and with addition of various concentration of Celtis turnipoti are shown in figure 1. The different electrochemical parameters determined from the polarization curves are listed in table 1. According to the data provided in table 1, corrosion coherence density decreases in the presence of inhibitor due to the blocking of the active sites of the mild steel. Increasing inhibitor concentration reduces current density. The inhibition efficiency increases with the increasing inhibitor concentration and reaches 92% at 3000 ppm of the inhibitor. Electrochemical impedance spectroscopy technique was utilized to investigate corrosion inhibition efficiency of the inhibitor. The Nyquist plots of mild steel electrodes in 1 molar HCl without and with various concentrations of Celsius 1040 are given in figure 2. The Nyquist plots are characterized by a capacitive loop at high frequency and followed an inductive arc at low frequencies in the absence of inhibitor and in the presence of small inhibitor concentrations. The capacitive lobe appeared at high frequency region shows the phenomenon related with the double electric layer. This arises from charge transfer in the corrosion process. The low inductive loop shows relaxation of species from the surface and shows unstable corrosion products at the metal surface. The diameter of Nyquist plots increases as the concentrations of inhibitor increase due to the adsorption of molecules at the mild steel. The surface semi-mesh of the matte steel after emerging into 1 molar HCl without and with the addition of 3000 ppm of inhibitor are given in figure 3. Without inhibitor, the surface is strongly damaged due to the excessive dissolution of mild steel. Many cracks and pits distributed over the metal are apparent. When 3000 ppm of inhibitor was added to the corrosive media, the matte steel surface looks more better and there is an inhibitor film on the matte steel surface, which reduces the dissolution of metal and provides remarkable prevention against corrosion. Detailed diaphragm analysis was carried out to obtain the average roughness factor Ra. The average Ra in uninhibited 1 molar HCl was found to be 110 nanometers. The addition of 3000 ppm to the aggressive solution reduces the Ra to 23 nanometers. The reduction in Ra can be assigned to formation of organic film on the surface, which has a compact structure and cover pits well. Contact angle measurements can give valuable information about the surface, film formation, hydrophilic or hydrophobic characters of surface, as well as orientation of molecules at the metal solution interface. Contact angle of mild steel after exposing to the HCl without and with addition of inhibitor are shown on figure 5. The average values of the measured contact angles for the specimens without and with inhibitor are lower than 90 degrees, which indicates their hydrophilic nature. The contact angle of mild steel surface exposed to 300 ppm inhibitor added in solution 72 degrees is higher than that of without inhibitor 62 degrees. The addition of inhibitor to HCl solution increases the hydrophobicity of the metal surface, so we can conclude that an organic film having a hydrophobic character forms over the surface and leads to the prevention of corrosion attack to the metal surface. Celtis-tomorphy is a good corrosion inhibitor for mass steel protection in 1 molar HCl solution, acting by reducing the rates of both anodic and cathodic reaction. The inhibitor is acting as mixed-type corrosion inhibitor. The inhibitory efficiency of this nature compound depends on its concentration and is higher than 90% at 3000 ppm, which is sufficient for the practical applications. This inhibitor should be applied at high concentrations for sufficient protection. Surface analysis measurements are in well agreement with the electrochemical results and confirm protective and well-distributed film over the metal surface. A significant reduction in the surface roughness was observed in inhibitor-containing solution compared with the solution without inhibitor. The inhibitor molecules adsorb homogeneously on the metal surface and forms a protective film. The solution sheet of the film has hydrophobic character. Thank you for your attention.